Hi guys, how are you? Today I am here with a general topic that is called BH3 reduction. So, what is BH3 reduction? BH3 is a very weak reducing agent which selectively reduces the carboxylic acid group in presence of ester or carbonyl group like keto. So, why BH3 is very selective? Why only COOH is reduced in presence of a ester or a keto group? So we will discuss this question, and we will follow the mechanism of BH3 reduction. So first, the carboxylic acid group, if it is treated with BH3, then it will be reduced to the corresponding alcohol. What is the mechanism of this reaction? If we draw the mechanism, first it will react with BH3 to form the ester, that is boronic acid ester. Now this ester has some characteristics property. It has the vacant p orbital, so this lone pair will come in resonance with this p orbital, as well as it can go into resonance with this carbonyl group. So this carboxylic acid, now it will react with another BH3 molecule, and BH will add into this C double bond O group, so hydrogen will be there. Now from this now again one BH3, from BH3 hydride will go into this carbon. So now after work of the product will be an alcohol. So this is the mechanism of this reaction. Now if we compare the other substrate like acid chloride or ester, amide and acid, now between these four substrate, these two are electron poor, has electron poor carbonyl group. These are much more electrophilic than these two, because here the Cl has strong minus I effect, as well as OR has strong minus I effect. So the carbonyl group, the electrophilicity of this CO is much higher. So these are much more strong, and to reduce this functional group we generally use lithium aluminum hydride to lithium aluminum hydride to reduce this functional group. But in presence of this functional group, if we have to reduce this carboxylic acid, then we will use much less reducing agent like BH3. It is a very weak reducing agent which selectively reduces the carboxylic acid group only. So in this case, as we can see that in this ester the oxygen lone pair will come in conjugation with this carbonyl group as well as this boron. So now after forming this ester, this C double bond O actually get activated, and then further BH3 will reduce this C double bond O to alcohol. Now in our question, if we follow this question, here one COOH and one CO2Me is there. If it is treated with BH3, then it will selectively reduces this acid. So our product will be CH2OH, and it will be as usual CO2Me. Another question, here is a keto group and here is a carboxylic acid group. So if it is treated with BH3, so the product will be, it will be reduces to CH2OH. It is CH2OH. So this will be the product. Now in this reaction, this is a very important question, came in GATE exam. Also this question came in GATE exam. So here if it is treated with BH3, as you can see that this group will reduce, so it will be converted to CH2OH, and it will remain the ester. Now here the alcohol will attack to this carbonyl group, and a lactone will be formed. 6-member lactone will be formed. So this will be the product. But if it is treated with lithium aluminum hydride, then it will selectively reduces this ester group, and COOH group will remain intact. So then the product will be CH2OH, it will be OH, this. Now it undergo lactonization, forming the product this, forming this product. So we can see the difference in product if we use the different reagent. So by using different reducing agent, we can reduce selectively either the ester or the carboxylic acid group. As well as here another example, if it is treated with B2H6, then this COOH group will be reduced. So the product will be CH2OH, it will be same. Now it will undergo cyclization. So if we rotate this carbon, here if we rotate this, it will be here, and this methyl will go above the plane. It will above the plane. Now cyclization will take place. So a 6-member lactone will be formed. Sorry, this will be CH2, here OH will be there, so it will attack. Now so the product will be this. Now one of the important question, this question came in GATE 2018. If this is treated with CF3 COOH, then BH3, then what will be the product? Now here you can see that here is a alpha beta unsaturated ester is there, and here is also an ester. So if if we treated with a strong acid like CF3COOH, then what will happen between these two ester? This ester will go hydrolysis and it will be converted to a carboxylic acid group. We will see the reaction. Here a tertiary butyl group is there. So if it is treated with H plus, then what will happen? It will protonate. It will be protonated. So COOMe. Now from this this bond will easily broken. Here alkyl oxygen cleavage will take place and there will be a stable carbocation formation happen here. So it will be the corresponding acid. This is the alpha beta unsaturated acid. Now if it is treated with BH3, then this will be reduced to CH2OH, because BH3 will selectively reduce the carboxylic acid in presence of an ester. So the product will be remain as usual, whereas it will be CH2OH. So this will be the product. So guys, if you have any doubt regarding this video, please let me know in comment box, and to get such interesting videos, subscribe my channel. Thank you. Have a good day.